Hey guys, welcome to part 2 of this video series. In this one, we'll be discussing the residential unit behind us. We're going to talk about the features and how the twist blocks were used to successfully build this maisonette. And I'm with...
Yeah, this is Samson Ontweka again. I was the site engineer for this project.
Yes, he's from Start Somewhere, Kenya, and I'm Muema from Property Noma. So, Samson, you can tell us where we are and the features of this house.
Yeah, this is a house that was done in Kibera. Where we stand at is Kibera, a place known as Karenend. And we developed this project here some few weeks ago. And it was a project that we partnered with a client known as the Livelihood Impact Fund, who are more rather the client for the project, and we implemented it in a period of two weeks. So it's a 4-unit houses that was done here, and I'd want you to understand how the costings, the timings, and all that. Yeah.
Okay. What is the size of this house in terms of square meters?
Well, the sizings of the house, that is the internal measurements, is 72 square meter. That is, we have 2 rooms on the ground floor. One room is 16 square meter. The other room is 20 square meter, which replicate to the first floor. So we have 36 on the ground and 36 on the first floor. So general gross and internal measurements of the room is 72 square meters.
How do you do the integration of the twist blocks from the foundation?
Well, to begin with, the foundation was a rebel foundation where we had excavation, the trenches where we need the walls to pass. And then again, we did a hardcore packing onto the into the foundation, and then we filled it with fine sand. Then afterwards, we laid a DPM. That is just in a nutshell how we did the construction, and then eventually did the concrete casting of the foundation. The total floor area for the foundation was 47 square meter. That is gross floor area for the raft itself. And afterwards, when now you start doing your steel, or rather your walling, the first course, you have to ensure that the the slab, that is the ground floor slab, is very level, because the twist blocks are a standard product. They are very standard, all of them. So if you mess with the leveling, you will mess with the entire walling. So you have to have a proficient mason who does the leveling. So for the first course, it has to be perfect. Then going upwards, that is how you ensure that you reduce the mistakes and the blocks fit in properly. Yeah.
Yeah, a big feature of twist blocks is the lack of mortar. You don't need mortar between the joints.
Yeah.
Now, when it comes to the foundation, do you need any mortar to connect the blocks to the foundation?
Usually, how we do it is the first course is concreted halfway. That is the first course from the foundation.
Yeah.
So it's concreted halfway, but it's done after you've done your leveling, after you've done your setting out. Once you've done your setting out and the blocks are perfectly laid, you do you fill the first course with mortar up to the height of half of the twist block, and then you wait for it to cure a little bit so that they are firm, so that when you're doing progressive laying of the blocks, you don't move them. So that is how we integrate it to the foundation.
Okay.
But then again, for instance, like for this case, this is a very special design. We have done a lot of advancements in our technology. So for this storage structure, we don't have reinforced columns, but rather we have steel bracings, in the sense that we have rebar bars at every corner of the room, just one rebar bar at every corner, going upwards to the beam, so it is tension to the beam.
Yeah.
The aspect, why do we do that? We do it because to prevent horizontal forces, and rather also to distribute the loading properly within the structures. So we employ a method known as tension bars, steel reinforcement at the corners of the houses. The walls themselves, the blocks are load bearing, so that is why we're able to achieve it without having reinforced columns.
Yeah.
Yeah.
So just to make things clear, there's no concrete pod within the
corners of the room.
Not within the corners. Even along the walls, they are just hollow.
Yeah. 90% of the blocks are very hollow, except for the ring beam only. That is the 13th course. The 13th course is filled with concrete all around the house, which is more rather the lintel, and it helps to distribute the load of the walling on the first floor,
Yeah.
respectively, very well, and also be able to hold the first floor slab. So where we have the concrete is only at the ring beam level.
Okay.
Yeah.
Now, looking at this house, this is the front side.
Yeah.
We can see there are some blocks that have color that actually matches with, I think, the color scheme that the client wanted. Like we have some bit of gold color that are on the blocks as well as on the steel railings. So is this something that you did initially before when you were producing the blocks?
Not really. When we brought in the blocks from the site, they were gray in color. That is their natural color on producing the natural color of concrete.
Yeah.
But reaching on site, when we are doing progressive walling for the blocks, we did a little bit of colored blocks into here on site. So we stacked some blocks together, let's say around 50 or 100 blocks, and then you're able to color it depending on the color that the client will have chosen. Then you'll be able to develop a good pattern for the client. So the client, that is livelihood impact fund, their theme, the theme color is this goldish color that you're seeing.
Yeah.
So that is why they recommended it to be integrated with the twist block.
Okay.
Yeah.
Now, this is a two-story structure.
Yeah.
How long did it take to set up the walling?
Well, this was a very special case. Now that we didn't have reinforced concrete for the columns, it took us 4 days in doing the entire walling from the first course to the 36th course. Yeah. So
Wow.
the back side of the structure has 36 course. The front side has around 28 course, so that you achieve that slope for the roof itself.
Yeah.
Yeah.
Because I can see it slopes
Yeah.
forwards.
It's a very simple roof system,
Yeah.
slanting roof system, so it slopes forward. So the back side has to be a little bit higher than the front side.
Okay.
Yeah.
Now I'm curious, what was the budget for this house till completion?
Well, active construction cost for this project was 1.1 million Kenyan shillings. That includes the raft, that is the ground floor slab, the walling itself, the staircase, the first floor slabs, which are also different. We try to integrate different flooring system for the first floor, and the simple roof, including the doors and the windows and the color that you're seeing here.
Yeah.
Yeah.
So you mean this house cost 1.1 M?
Yeah.
For a maisonette?
Yeah.
Wow. That is a game changer.
Indeed.
Yeah. Aye, that's one of those technologies that really sell the affordable housing criteria, you know?
Yeah.
How many blocks were used for this entire house?
For this entire house, we were able to adapt or use 1700 twist blocks, which is more rather 2 tracks, because we used an FRR track, which carries around 850 blocks per trip. So we were able to utilize 1700 twist blocks. So that is also inclusive of some markup for breakages. Yeah.
Oh, okay. Talking about transport, are you able, as Start Somewhere Kenya, to build for anyone around the country? Because the projects that we've seen, they're near Nairobi or near Kibra. So are you able to do it in other towns within the country?
Yeah, yes. We are very much able to do projects that are outside Nairobi County, because like for instance, on the western part of Kenya, in Kisumu, we have a factory there near Ahero, and that factory is able to service the customer base in that region. And projects within Nairobi, we're able to supply comfortably from Kibera. Another instance is we have had clients all the way from Meru and Kirinyaga. Those people have been able to buy blocks from Nairobi and be able to build in those respective regions.
Yeah.
But even in case we've had interest also towards the coastal region.
Yeah.
And the way we approach it is we're able to produce the blocks from site depending on the complexity of the project. So if a project is huge enough, like it can utilize up to up to 5,000 plus blocks,
Yeah.
we can be able to produce on site. So what we usually do is do some tests on the sand that is available, on rather the materials that are available in that region, and then be able to move some of our equipment. That is, as you saw in our earlier segment, we use only a mixer and a vibrating table and the molds.
Yeah.
So we can be able to pack them in a container, then transport it to site where we can be able to produce the blocks from that end. But we have to do first the sand analysis for the sand that is locally available in the area we need to develop.
Yeah.
Yeah.
So suppose I'm that client who has built something like this,
Yeah.
but I'd like to move to another place. Am I able to get all my blocks, put them in a truck and move with them to that new site?
Yeah, as one feature of the twist block that is very advantageous to the client is it allows you to reuse most of the twist blocks. Up to 90% of the twist blocks can be reused. The blocks that you cannot reuse are the blocks where you have concrete columns and beams, but the other blocks you can be able to use them. To use an example of this prototype, so with it we say up to 95 or so percent of the blocks can be reused, because now we don't have reinforced columns, we only have a reinforced beam alone.
Yeah.
So you'll be able to remove the roof itself easily. The staircase itself is not permanently done. It's just screwed onto the ring beam, so you can just remove it entirely, and then you'll be able to remove all the blocks properly from top to bottom, then be able to save up to 95% of the block. So it allows you, the client, to be able, if you have maybe future designs needs, you can be able to redesign your structure, take away the blocks, and then reassemble them again to the design that you want. So that is a feature of the twist block. We say that most of the blocks can be reused.
Yeah.
Yeah.
Now, can any stone mason build using the twist blocks, or do you need expertise that come from your company?
Well, the client that we've had from Kirinyaga and Meru, they were able to do these projects on their own. The only advice that I could give to people who want to use it is to the client. If you are not doing a storage structure where you need reinforced columns and beams, depending on the complexity of the structure, if you are doing only a ground floor structure, it is easily adaptable. You can just buy the blocks. You come to maybe our factories, we're able to at least show you how we do different types of cuttings, like the special C cuttings, the round blocks cuttings using an angle grinder, and then with it you'll be able to use the blocks. Also, on top of that, we offer a service known as the block plans. That is a service that we offer to the client, as in we give the client every plan of the block from the first course to the last course. So with the block plans, you as a client, using any fundi or mason, they can be able to adapt it and build as per the block plans and be able to achieve it on its own. So in Kibra, we've had people who've bought blocks, they've done some perimeter wall, they've done some stalls. So it is very, very adaptable to any person, regardless of the skill that you have, because it's just a plug-in system where you just stack the blocks all together. As long as you understand that the first course, it should look like, the next course should be in the opposite direction. Yeah, to remove the aspect of straight joint within the blocks.
Okay.
Yeah.
Now, I have a question, because we are using the dry stacking method,
Yeah.
where we don't need any mortar between the joints.
Yeah.
Is there, can a client face an issue of water seepage? Say when it rains this way, can water seep into the house?
In the project that we've done in Kibra and within Kibra, within other regions, that is in Meru, Kirinyaga, we don't have instances of lateral rains going into the house, because once the blocks interlock, they are meant to form a seal joint, a zero joint, where you don't expect to have maybe water going inside, insects, something of that sort. So yes, you cannot have water going into the blocks from lateral rains.
Okay.
Yeah.
And because the blocks are hollow,
yeah,
do they offer thermal regulation and noise regulation?
Yeah, that is also thank you for asking. That is also a very, very advantageous aspect of the twist block. The hollow nature of the twist blocks allows it to trap enough air. So as we all know, air is a poor conductor of heat. So it is able to microclimate the temperatures of the internal from the temperatures of the external. If you just go into the rooms, you'll feel a little bit of microclimating from the external. So during the day, when it's very, very hot outside, the internals or the inside of the room is a mild climate.
Yeah.
And during the night, when it's cold outside, it's warm into the rooms. So
Yeah.
that is an aspect of the twist block. So the hollow nature plays a very, very crucial advantage to the client.
Yeah.
Yeah.
Okay. Now, when it comes to doors and windows,
Yeah.
What happens?
So for instance, let us use this one here. If you can see, this is a door. The way it was fixed here, usually with the block plans, depending on the plan that the client has given us. So we're able to simulate block plans with the measurement that the client needs the house to be. Then we leave the opening for the doors and the windows into the modules of the twist block. So once we have an opening of that, what we do, like for this case, we're able to only concrete 3 pieces of the twist block. So this is this colored piece here, this one here, and the down one, the down part. So this special C is filled with concrete. This one also is filled with concrete, and the downmost part, as I had mentioned earlier, always the downmost part is filled with concrete halfway.
Yeah.
And then from there you're able to screw. If you can see from this point, there's a screw here, so it is fixed onto the concrete itself,
Yeah.
so that the door is held firmly onto the walls.
Okay.
Yeah, that is how we go around with the doors and the windows.
Yeah.
Yeah.
Samson, you can take us through a brief tour of this house.
Okay, thank you.
Yeah.
Please come. So this is the smallest unit here in the current project, and it's around 16 square meters in terms of floor area, that is the internals. And the client was perceiving to have a very comfortable bedsitter for people in Kibra. So as you can see, he has done a little bit of setup here. So we have a bed there that can comfortably fit in. We have a sofa, we have a table, we have a kitchen area,
Yeah.
and we have a washroom area. So for us here, we were able to utilize some different types of board. This one here is known as eco board. It is very, very good. It works well with our twist block, as you saw in our other projects like the global one.
Yeah.
The partitioning for the toilet was a eco board.
Okay.
So it is water resistant, and also you can be able to apply tiles on it. So it works well with cement and the tiling. So we use it because you're able to maximize on the space that you have, rather than using the twist block in doing the partitioning for the toilet.
Yeah.
Because the twist blocks are kind of broad.
Yeah.
So we integrate various technologies. Like for this case, we use the eco board.
Okay.
Yeah.
Now, because of the smooth nature of the twist blocks,
Yeah.
are they able to hold tiles properly?
Yes, the smooth nature of the twist block are able to hold tiles properly. In the areas where we have the joints, if you are able to apply some mortar, or rather the cement, where you want to stick your tiles, you can be able to apply it there and then be able to stick your tiles appropriately. So these joints, they give you a grip, but also you could be able to at least stack it with an angle grinder and then be able to stick cement if you need.
Okay.
Yeah.
Now, judging from this bedsitter,
Yeah.
I'm guessing the client will leave it as it is, or will they come later on to do plastering and painting?
No. The client are from the United States, so they love the block the way they are, the architectural appeal of the block, their natural nature. This is a feature that they really like, and they wouldn't want to plaster the internals of the wall. So what they do, they requested us to do a simple pattern for the blocks, so that you have a different color pattern, which is a very good finish for them.
Yeah.
Yeah, so this is, as it is, it's the final product for the unit.
So for a client who would like to save money on plastering and painting, they can just use the twist block as it is.
Yeah, we say that the twist block is the only material that you'll need on site. So once you've bought the twist block, and if you're doing a ground floor structure, you just stack them appropriately, do some color schemings on the blocks, and then that is it. So you'll be able to save on the other materials. That is the mortar that you could have used to do the joint work if you were to use a conventional building way, the plaster itself, the formwork for columns and beams and such, and the way we do our electrical works. So the conduits pass through the blocks, the plumb works pass through the blocks. So the client, you're able to save a lot in terms of material and the time itself and the labor that is affiliated to the project. Yeah.
Okay. I can also see that the supports for the countertop, they used the twist blocks.
Yeah.
Do they have concrete or are they hollow?
Those twist blocks, they are very, very hollow. They don't have concrete in them.
Okay.
So the twist blocks are very low. They are load bearing.
Yeah.
Like if it was able to support the whole structure without having concrete frames, so why would it not support this the kitchen cabinet itself?
Okay.
So the twist block are very load bearing.
Yeah. Because I also have international clients. There are some clients who are watching. Would like to know the earthquake performance of twist blocks.
Okay.
How do they perform in areas where
they are earthquake prone?
Yeah.
In areas where it's earthquake prone, the twist blocks are tried and tested. Recently, we've had earthquakes within Kenya. You can remember, and we've had buildings standing from 2018 till date. So it was tried and tested, and it works very, very well with earthquakes. Also, in the sense that they are broader, so they have 250 mm in terms of broadness. So they are very stable compared to the other building blocks.
Yeah. Now, when it comes to cost, how do you charge it? Do you charge per square meter or per block or per floor area? How do you do it?
It depends with what the client wants. If the clients want to develop the property themselves, we just sell the blocks to the client. If the client also wants us to build up the property for them, now we'll come in and do the selling of the block and the planning of the project itself. Then eventually the construction, that is the project management of the project. So we have different packages for the client. If a client opts to buy the blocks, you can buy it. If the client wants our architectural and structural planning, we do the structural planning, architectural planning, and selling the blocks, and then maybe a contractor can implement it for them. If the client wants a full package, where now we come in and do everything from planning, from project management, from blocks and everything, we do it from our end.
Okay.
Yeah.
Okay. So, for example, for this particular house, how did you do the costing?
For this particular house, I came in to do the walling for this house. So the client was able to do the foundation himself. So Livelihood Impact Fund partnered with another organization known as the Global Property Advice. Their company is here in Kenya, international company is here in Kenya. So the Global Property organization was able to develop the ground floor slab, and then we as Tatsama, because we are walling experts, we came in to train them on how to do the walling for this property, and also be able also to learn from them where we can. So that is how we handle this project. So we just charge for engineering fee. That is practically my time here as an engineer, and also we were able to cost for the products, for our products, that is the twist blocks now, and the architectural and the structural details for this. So that is the area where we were when we were engaged in. Going back to the initial costing for the final costing for this project, which was more rather 1.1 million Kenya shillings per floor area, that is 72 square meters, you'll be able to achieve a cost of around 15,000 per square meter. So our costing per square meter, which is directly proportional to the floor area, is 15K for this project, and it's a very simple project without reinforced concrete columns for the columns, reinforced concrete for the columns, and we're able to achieve a very, very good figure, that is 15K per square meter.
Okay.
Yeah.
We have a tap here.
Yeah.
So I'm assuming there's a PVC pipe here for plumbing that passes through here, and then this is like the access point.
Yeah.
So this is it's that easy for clients to now do or even not even for clients, for plumbers and electricians, to pass through their pipes.
Yeah, the twist block allows the plumbers a easy job, that is passing through the pipes and through the hollow nature of the block. So we have pipes running through the twist block, and they have access to down there. Now it is connected to this tap, so it's very easy for any plumber to have that skill of just integrating the pipes with the twist block. Also, it doubles up to the electrical system. So the conduits, they pass through the hollow nature of the blocks, and then you're able to screw your cutouts, your socket, and then you're able now to do the lighting from that end.
Okay.
It's very easy to integrate the plumb work and the electrical work with the twist blocks. You will see it in the coming construction phases, so that you're able to understand how we do our electrical and plumbing works.
Okay.
Yeah.
We are now in the second room, in the ground floor. Now, Samson, you can tell us the size of this room, and also what you've done here to support now the first floor slab.
Yeah. So the size of the internal size of this room, it's 20 square meter. That is the size. It's same to the floor above it. That is the first floor room. And how we've done our roofing from above, if you can be able to see it from that end, we've been able to utilize T-beams. These are T-beams. We get it from Eco Concrete, and then the beams are the ones which have held the first floor slab intact. So they transfer the loads to the beam of the twist blocks round. That is where you see the blocks have been cut. That is the ring beam course.
Yeah.
So that is the only course that is concreted in this whole structure.
Yeah.
So the T-beams rest on top of the beam that is casted, and you're able to distribute the load properly to the entire structure. Yeah.
Okay.
Well, in this room, the roof itself, or rather the ceiling, is very different from the other one. The other one, you had utilized T-beams. For this one, we have utilized rod hollow sections, or rather rectangular hollow sections. So they are the ones which have held the marine boards, and then on top of the marine boards, we have a very good finish atop of it. So both of them, they have a concrete finish atop of them. It's only that we are exploring which option is very affordable in doing this. So this one proved to be more affordable than the precast beams.
Okay.
This is a 1 meter staircase. That is in terms of its width. It's very independent from the structure itself. If you want to remove it, you can be able to just unscrew it from the screws that are fixed onto the ring beam. And we had achieved a very good cost for this timber and metal staircase of around 60,000 Kenya shilling, which is very affordable compared to conventional, or rather a concrete staircase. Yeah.
Okay. This is the room on top of the bedsitter unit that we saw below, and judging from its size, it's still similar to the one beneath, right?
Yeah.
Okay.
So this room is also 16 square meter in terms of the area. So it sits right on top of the bedsitter, as you mentioned, and the floor itself is here to be concreted, to be finished. That is a nice screed atop of it. The concrete slab that is casted atop of the marine board is around 50 mm. So it's a very thin concrete slab, and what is remaining is just a simple finish. As you can see, we had tried to do a simple finish from that end. So we are just waiting for the slab to cure, and after it has cured, we'll do a very simple finish to it and give it a very clean finish.
Yeah.
So on to the next room.
Okay.
So again, this is the room that sits on top of the 20 square meter area below, where we have the T-beams as a ceiling for that underneath under room. And here also we did a very good finish. It's a concrete finish. So what we did onto the T-beams, the inverted T-beams, we were able to put formwork. That formwork was more rather iron sheets from below, and then we did some mesh wire, or rather A to A92, that is like BRC, but it's more rather the simple mesh that you always see.
Yeah.
And then we did a simple concrete atop of it that is mixed with fiber and wood glue. So
Yeah.
wood glue has that bonding property, and the fiber itself, it ensures that the slab itself does not crack. So both of the floors, we have fiber into the concrete,
Yeah.
so that the concrete itself does not crack.
Yeah.
Yeah.
Now, final question.
Yeah.
How do you deal with corners for partitions and also for the perimeter wall?
Well, the corners with partition, it depends. There are instances where you have the T-junctions. Well, with the T-junctions, the block plans will give you a good way of how to handle it, because they'll give you special cutting for that junction. Then if you cut your blocks into the exact detail that you're given, it will be very, very easy to integrate it. The roof itself is a very, very simple roof system. So we have triangular sections. The yellow sections that you are seeing, they are made out of marine board. So they are triangular sections. And then we have 4x2 metal plates that you see, timber plates atop of every layer of the block. So that 4x2 is held down by the hoop ions. If you can see clearly, we have hoop ions. So the hoop ions come from the ring beam course. So the concreted ring beam course has the hoop ions, which run through the blocks onto the base, the timber plates, and then they held down the roof in that sense. So it's a combination of metal and timber roof, very simple slanting roof. So in between we have purlins, metal purlins that are 2x2 metal purlins distributed in good spans, and then on the end we have the plates, that is the timber plates. They are more rather the purlin, the wall plates. Then atop of it we have gauge 30 iron sheets, full length. So it was around 8 meters. So we utilized a bit of it. So the costing for the roof was more rather very, very affordable compared to the conventional roofing, because now here we don't use trusses. We've just used a very, very simple system that the client needed.
Yeah.
Yeah.
And for those clients who want complex pitched roofs, is it possible with the twist blocks?
Yes, yes, yes. It is very, very possible with the twist blocks. If you want a complex pitch roof, what we do structural detailing for the roof itself to ensure that it's able to bear with the wind loading and such.
Yeah.
So we detail it properly and integrate the trusses as the client has perceived. Then you're able to install the roof, so it works with any type of roof.
Okay.
Yeah.
Now we are left with part 3, where we'll showcase 2 schools that were built using the twist blocks. They have different designs. One school is 3-storied, while the other is 2-storied. You'll see them in part 3. So stay tuned, subscribe if you haven't, so that you get notified when part 3 goes live. And with that, thanks for watching this video. We shall see you in the next one.